squared. All right, so, and there's two versions of it. So first off, they're both minus 3 squared, but the first one does not have parentheses, if you can see that okay. Feel free to move up if you have trouble seeing that. So the top one has no parentheses. The bottom one has parentheses. Maybe I could even do this and make it bigger. Let me see. There we go. So number 1, yeah, the first one has no parentheses. All right, and then the second one has parentheses. What's the difference? What's the answer to the first one, and what's the answer to the second one?
9.
Yeah, the first one is actually -9, and the second one is +9. Do you know why? Let me show you. The first one, the negative is not repeated. You see, because it's not in the parentheses. See that 2 power, which says, make 2 of them? It only applies to the number right next to it. It just makes 2 3s. It doesn't make 2 negative signs unless there's parentheses. And then that's 2 -3s, and we all know 2 negatives makes positive. So you see the difference there? So it's kind of like a little trick. You just have to remember, when there's no parentheses, there's no repeating of the minus sign. It's just 1 minus, so the answer comes out negative. So it's just like a little trick on that. All right, I'll go to number 2 here. What was number 2? So 9x to the 4th, 3x cubed. 9x to the 4th, 3x cubed. All right, so yeah, this section is all about the power rules. We're doing a quick review. It kind of is basic algebra, kind of intermediate put together. We're doing a quick review of the power rules. Now, what are the power rules? Let me just write it here for you. You multiply the numbers in front, and you add the powers. So when you're multiplying 2-letter expressions like that, what you do, my writing's a little sloppy. These are 4s, not 9s. And that's a 9 in the front. Oh, was it? Maybe you're right. Maybe I miscopied it. Is that what it was? Yep, you're right. Thank you. Okay, so we multiply the numbers in the front, and we add the powers. That's how you multiply letter type things. So 9 times 3? 27. To the 7th, exactly. Multiply the numbers in front, add the powers. Good on that? So that's the rule. If you're good, I'll go back and get number 3 here. So 7, z to the 4th over 4 over 4th, okay. Number 3. Z to the 4th over 4. All to the 4th. Okay. So we have those parentheses. We have a 4th power. And so we want to, we're going to let that power do his thing on everything in the parentheses. Now, what does the power do? Let me write the rule for you. I'm assuming if you've seen it, you're probably a little rusty on it. Powers outside parentheses multiply powers inside parentheses. So this 4 is a power outside parentheses, right? So what's he going to do? He's going to multiply all the powers inside the parentheses. So he's going to go boom like that. And so this will be z to what power? 16, because 4 times 4, right? He'll multiply that. But now here's the $1 million question. What's he going to do on the bottom?
4 to the 4th.
Good job. Yeah, because really, you might look at this and think, well, he's not a power, and that's true, of course, but he has a power, huh? What's his invisible power? 1. Remember, like an X or a number that doesn't show his power really has an invisible 1 power. Everything has a power. If it's not showing the power, it's really got an invisible 1 power. Okay, so what? Well, that lets us follow the rule. Powers outside parentheses multiply other powers. Powers with powers, right? So that 4 is going to hit the 1. It'll be 4 to the 4th. Good so far. And then what is 4 to the 4th? Well, it means 4 times 4 times 4 times 4. The top just stays as it is. And so then just use your calculator, some big old number. 16, 31, is it 256? Yeah. 256 in your calculator. Whoops. A little scribbly there. And there it is. So what happened there? Powers outside parentheses multiply powers inside parentheses. Powers with powers. So notice that power 4 never hit the base of 4. He hit his power. He hit both the powers, didn't he? Powers multiply powers. And then the parentheses drop off, don't they? Whenever something outside parentheses go in, we drop the parentheses, don't we? You notice that? Good there. Feel free to stop me or speak up if you want to talk more about it. Let's see, number 4, minus 3w to the 16th, all to the 4th. Minus 3w to the 16th, all to the 4th. All right. Let's do this. Let's determine the sign, like positive or negative, right off the bat, and then we won't have to mess with that. We can just focus on the other stuff. Is this thing in the very end, when all is said and done, going to end up being positive or negative? Good job. How do you know it's going to be positive? 4. It really means 4 of these, doesn't it? So you could write 4 of those. I'm not going to bother to do all that, but that's really what it means. So it means 4 of those and 4 negatives is positive, right? Because every 2 negatives make a positive, don't they? So the first 2 negatives make positive, the next 2. What if that was a third power? Negative, because that would be 3 of those, and 3 negatives is negative, right? Because the first 2 would be positive, but then the last one would turn. It's like a light switch, right? You know, positive, negative, positive, negative. You know, so if I do it an even amount of times, we're back to the way we started, right? So if you just had 2 negatives or 4 negatives, then it's going to end up positive. But if you had 5 negatives, it's back to negative, isn't it? Right? So we just look at the power here, and we say, oh, 4 negatives. Got to be positive in the end. And then we can just forget about the sign. So it's going to be positive something. You don't have to write a plus sign. Just putting nothing is fine. But for emphasis, I'm just going to say plus. We know it's positive. All right, now let's do the numbers and the letters. Can you take it from there? Let me let you do next step. Yeah.
So if it has a negative and a positive, what is it going to be?
So yeah, like a negative number times a positive number is negative. Yeah. So if you just have 1 negative, the answer is negative. If you have 2 negatives, that'll be positive. Right. 2 negatives is positive when they multiply. Exactly right. So that's why 4 negatives is also positive. Yeah. Good. So now can you do the 3 and the W and that stuff? What's going to happen? What's the rule there? Powers outside parentheses. Multiply. But what do they multiply? Finish that sentence. The second part is really important. What do powers multiply? Powers multiply powers with powers. So keep saying that to yourself and make sure you carry that out. Powers with powers. Powers hit other powers. They don't hit bases. So what am I talking about? So here I see the 16. That's a power. That's the only power, though. No, not a true sentence. That's not the only power. The other one's invisible. The 1 right there, huh? Don't forget him, right? So it's going to hit both those, isn't it? That 4 is going to go boom and boom. And it'll be 3 to the 4th, W to whatever 4 times 16 is. I think that's 64, isn't it? So far, so good. We just have one more step. We've got to figure out what is 3 to the 4th. Just use your calculator. It's going to be 81. And we're done. Does everybody see what happened there? Powers multiply powers, don't they? Powers multiply powers. So everybody that doesn't show their power really has a 1 power. They really have a first power. Powers multiply powers. Questions on that one? All right, we good? Let's see, number 5. 12z to the 9th, 10z squared, all right. So number 5. 12z to the 9th, 10z squared. All right, that should be an easy one. Crank that one out. That's just rule number 1. Multiply numbers out front, add powers. So 12 multiplies 10. 120, right? Out front numbers multiply, powers add. Right? So that's going to be z to the 11th.
Yep.
Now, why don't they multiply here?
Because that's not the rule.
Yeah, because there's no powers outside parentheses. There's not like a 7 outside the parentheses, right? That was powers outside. Well, like number 4 that's up here. See, powers outside multiply powers inside, but that's not what we have here. We just have 2 powers inside, so they just add. See that difference?
So when they're both inside, you add.
What's that?
So when they're both inside, you add.
When you're both inside, you add. Correct.
I just follow the rules.
That's perfect. Just follow the rules. It'll all be good. Good? All right. Sometimes it's hard to keep all them rules straight, though, is the hard part. All right. Evaluate. 2 to the minus 2, 6 to the third. 2 to the minus 2, 6 to the third. Okay. So number 6.
But most of the time, if you don't follow the rules, won't the equation come out like a null set? And I know we haven't done any null sets.
It would kind of depend. Some will. Some will. All right. What's up with this? What's with that little negative number up there in the power zone? What is that? Anybody know what that means?
That's a negative power.
Yeah, but what does it do? I mean, like for example, let's think about powers. You guys know what powers are, right? Like if I write 3 and I put a little 2 in the upper right-hand corner, you guys know what that means. What does that mean?
It'll be 9.
Right, and why? What if you were explaining to a young child who had no idea what little numbers in the upper right-hand corner meant? Why is it 9?
Because it's 3 times.
Yeah. So that little number in the upper right-hand corner is really a repeat symbol, as you know quite well, huh? It means repeat 2 3s multiplied together to be 9, right? That you know, huh?
And wouldn't the negative 2 do the same thing, so it'll be a negative at the end of it?
So what if I put a 4 up there? What if I put 2 to the 4th power? Let's make sure we're clear, and then we'll go to the harder stuff. What's 2 to the 4th power? Well, and you're saying, well, that just means 4 2s, and yeah, it comes out 16, huh? Right? So whatever number, let's be super clear on this, whatever number you put in the upper right-hand corner, that's a repeat symbol, which means repeat the 2 4 times multiplied together. Repeat the 3 2 times multiplied together. Right, okay. So what does it mean then to put a negative 2 there?
You're still going to repeat. It says
How do you repeat something a negative amount of times? What if it says, hey, Dennis, I want you to do that assignment negative 2 times? What does that even mean?
you just do a negative 2 times.
Explain to me what that even means.
Do it 4 times.
How's that different than doing it 2 times? Does that mean you just put like a negative number on it both times?
No.
Is that what it means?
Do 2 times 2 and then put a negative symbol.
Just put a negative in the end?
Yeah.
So it just means just repeat it twice and then throw a negative in the front.
Yeah.
But maybe it should be positive. It's 2 negatives.
No.
Does it mean that? Does it mean 2 negatives?
That's not what I'm looking at. It just
Does anybody know what it means? Not undefined. Nobody knows. No? It does. You've had some intermediate algebra. Yeah, do you know what the answer is to it? Yes. It puts the 2's on the bottom. The negative power throws the 2's to the bottom, and they're not negative at all. And the answer is 1/4. Now that is weird, isn't it? Doesn't it feel like they're just making this up as they go along?
Yep.
And they're just making it as weird and as hard as they can because they have an agenda to just weed some people out, right? They took me into the conspiracy when I was just a baby. I'm joking, but it feels that way, doesn't it? Would you believe it if I said to you that it has to be that way? And that within 1 minute, I can convince everyone in the room that they had no choice in the matter. But it absolutely has to be a fraction. Let me show you. Because that's what I enjoy about math. Not all these rules. I'm really not into all the rules. But I'm into how they're beautifully true. How they follow truth beautifully. Let me show you. Why in the world would a negative power be a fraction? I mean, where's that coming from? Well, let me show you something. 2 to the third. What is it?
2 times 2 times
Yeah, 2 times 2 times 2. And the answer is? 2 times 2 is 4. Times 2 is 8. Good. Okay. 2 squared. What is it? 2 times 2, answer is 4. 2 to the first power. Just 2. Yeah. Okay. Now hold on. What's next in the order, by the way? So I'm going 2 to the third, 2 to the second, 2 to the 1, 2 to the what?
0.
0's got to be next. And then what comes after that?
-1.
-1. Now, I don't know what the answers are yet,
Right.
but I'm just going to follow the yellow brick road to get to the wizard. I'm just going to follow the
The
pattern.
whole thing with whole numbers and
No, I'm just going to, nothing deep, nothing that's outside of your reach. Look at the answers. Let's just follow the pattern. What's happening every time in the answers? And then we'll just do the same thing. Yeah, isn't it dividing by 2? So 8 divided by 2 is 4, divided by 2 is 2. So what's the next one got to be? Whoa, we were doing so well. Let's try that again. 8 divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 2 divided by 2 is 1. Divided by 2. 1 divided by 2? It is a fraction. You see? It's just the pattern. What would be the next one? Another 2 in the bottom. Anyway, that's good enough. Right? You see the idea? That's what happens. I think that's just what powers do, don't they? Every time you go down in a power, you're dividing by 2. So it's got to. You're putting 2's in the denominator. That's what you're doing. Math's just following the truth. That's all they're doing. Negative powers must mean divide. That's what they mean. It makes sense if you think about it this way. What do numbers in the top mean? They mean multiply, don't they? So what's the opposite of multiply?
divide.
So negative powers have to mean divide. If positive powers mean multiply, negative powers have to mean divide, don't they? I like that about math, that it's beautifully consistent. All right, so therefore, now that we've said all that, let me give you the clear rule. So the rule is this. Here is the rule. Dennis wants the rules. So here, he's going to follow all the rules. He's promising. So 2, I'll just make one up here. Or I'll just do 2 to the minus 2. 2 to the minus 2. What you do with negative powers is you go 1 over and then you make the power positive. Right? So that's what we just learned, right? It means divide. It means that 2's on the bottom, which means 1/4. So let me put it to you this way. Having shown you the truth of it, let me give you something handy to help you remember it. What I always tell my students is negative powers are unhappy where they're at. They want to jump to the other side. Like somebody unhappy at their job, they want to jump to a new job. Negative powers are unhappy where they're at, and they're going to jump to the other side. What do I mean? Well, right now he was over 1. Anything alone is over 1. And where did he end up jumping to? The bottom. And then the power became positive. That's what negative powers do. They're negative. They're unhappy where they're at, and they're going to jump to the other side of the fraction. They're going to jump to the bottom. And then, after they get to that new job, their power becomes positive. And then you just work out the problem like normal. 2 squared is 4. Make sense? So let's do it on this question. So negative powers jump to the bottom. And then they become positive. So let's finish up this problem. All right, so this one has a negative power. The other one has a positive power. Right? So he's happy. He's happy at his job. He's staying put. But this guy says, I'm unhappy, I'm negative, I'm going down. So the 6 to the third will stay on the top, and the 2 squared will go to the bottom. And when he goes to the bottom, is he still negative down there?
No, he's positive.
No, then he becomes a positive. He's happy at his new job. Did you track with me there? I just took this guy that had the negative, unhappy power, and he jumped to the bottom. Now, you might say, well, yeah, let's just leave it at that. Jump to the bottom, and then you just use your calculator. 6 times 6 times 6 over 2 times 2. Some big number, I don't know. There's 216, yeah, over 4. I think it's 54. What is it? 54. It's our final answer.
How I do the cross cancel.
Yeah, that's good too.
1 over 4.
Yeah, that's a good way to do it too. Yeah.
You can cross count.
Yeah, so she's just saying she'd cancel that here. 2 into 6. 2 into 6. Or something like that. Maybe cancel somewhere else. There's a lot of places you can cancel. I better move on. Questions on the negative powers? That make sense? So negative powers jump to the other side. All right, so number 7, they're going to give us both these. So they never want us to leave negative powers. So those both have negative powers, don't they? So what are they going to do? Yeah, they're both jumping, huh? He's going down, and he's going up. Now, what if only one of them was negative? Then only that one would jump, and the other one would stay put. Yeah, so the y's going up, and then his power becomes positive. The x is going down, and then his power becomes positive. He's happy after he jumps, and that's it. There's nothing more we can do on this problem. That's all we do. In the end, we make the powers positive. So negative powers are unhappy where they're at. They want to jump to the other side. All right, let's go back. Let's see. Number 8 here. 1 over 9 y to the minus 7. Yeah, that's a good one. Okay. All right, so 1 over 9 y to the minus 7. So. All right, try that one. Same kind of thing. You know the drill, right? Negative powers are unhappy. They jump to the other side, and then they're happy. Then they're positive. So go ahead and do that. But be careful. It's a laden trap. There's a certain mistake most people make. It's a tiny mistake. It's a good learning lesson. It's a good time to make mistakes right now. That way you won't make them on the exam. All right, so what's the answer?
9y7.
Is the answer 9y to the 7th?
No.
Yes.
That's the mistake.
It goes all the way up to the top.
Okay,
Is it add?
so doing that is not following the rule. But if you're like, no, I follow the rule. Well, let's be really careful. What is the rule again? Negative powers
Jump to the top.
jump to the top, or the other side.
So that one
So-
will go to the 7, right?
So who is that negative 7 power on?
It's on the Y.
Well, the y. Is he on the 9?
No.
No. Does the 9 have his own power?
Yeah.
Invisibly sitting there?
1,
Yeah. So has he got a negative power?
yeah.
No. So is he jumping? No. Only the y is going to jump, huh?
So it's gonna be one way.
Yeah, right. So the 1 also has a 1, so it just stays put. Y to the positive, and the 9 stays down. Huh. The 9 doesn't have a negative power on him. Just easy to make that mistake, huh? Now, what is 1 times y to the 7th? That's just y to the 7th. That 1 doesn't do anything, so we just get rid of it. Right? 1 times anything, that doesn't change anything.
But is it still the right answer, or you put 1 Y?
They would consider this unsimplified.
Okay.
That'd be like saying 1 times 3. People would go, why are you saying 1 times 3? Just say 3. That's what the program wouldn't be happy if you left that 1 there. Does that make sense? On that, so watch out. Don't let them get you on that. So just the item that has the negative power jumps. Everything else has a 1 power and stays put. All right. So let's see. 4x squared over x to the minus 3. Okay. Number 9. All right. All these little power rules.
Oh, sorry. Yeah.
So what's the rule? Powers outside parentheses multiply other powers. Make sure you know those 2 power words. So he's going to multiply this power. And is there another power in there? Invisibly there on that 4. Remember, every number, every letter has a power. If it's not showing its power, it's a 1. Invisible 1, yeah. So you got to keep track of that. So it's going to multiply both those, right? So that'll be 4 squared x to the 4th
And then
over.
And then the friend wants to be up there. So
Exactly. Yeah, I'll take it one step at a time, but you can do it all at once. Yeah, totally. Yeah, and then this guy, negative powers are unhappy where they're at. They're going to jump to the other side. How about the ones on the top? Are they jumping down? No, they're happy, huh?
They're positive.
They're
So
positive.
the fraction turns into a whole.
So we get 4 squared x to the 4th, and then that x to the minus 3 jumps up top, becomes x to the plus 3. And we have no more denominator.
No.
So don't even need a fraction anymore, huh? Good so far? Right? So the only thing that was on the bottom jumped up to the top, so we have no more bottom. It's no longer a fraction.
Yeah.
Right? And then, what's 4 squared? 4 times 4? And what do you do with these x's?
You add them.
Do you add them or multiply them?
You add them.
Well, I already said the answer, huh? So you know you. But how do you know? How do you keep all that straight? You know what I think is easiest? Just think what it means. What does x to the fourth mean? Doesn't it mean 4x's?
Yes.
And what does x to the third mean?
3x.
So how many x's we got?
7.
Yeah. Yeah. 16x to the 7th, huh? Just following the truth of these rules we've learned.
That was weird because I actually did that in my head. That's why I thought I was wrong.
Sometimes it works better that way. What's that?
No, my,
All good? Yeah, we can't add this guy to them because he doesn't have the same base. He's a different base. Yeah, good question. No, that was a good question.
And now it makes sense why you said it doesn't matter if you start the rule at the beginning or not.
Yeah, you could jump the thing first or do the power first. Yeah, either one.
Get all the x's together.
Just get them together eventually. Yeah. Good. Starting to make some sense. All right. Hopefully it'll make more sense as you practice it at home too. Let's see. 16y to the 11th over 4y to the 4th. 16y to the 11th over 4y to the 4th. Over 4y to the 4th. All to the, was it negative 3?
Yeah.
That was, yeah, thank you. All right. Try that one. You know what I would do? Yeah, let me give you a tip on this one. There's a lot of ways now, but one of the ways is going to be way easier. I would simplify that inside first. Either way's okay, but it's going to be a lot easier to clean up. So no, let this negative 3 just chill for a minute. Don't bring him in. Even though it's technically okay, that'd be so much harder. Just first simplify that inside. Just pretend the negative 3 is not even there for a minute. And just do the inside. Clean that up as much as you can. When you're all done with that, then put the negative 3 back on there and let him do his thing.
When you simplify, will you get rid of the parentheses?
No, you only drop the parentheses when the outsider comes in. Yeah, right. So just do the inside first. Let the minus 3 just sit there until you get the inside nice and tight. And then let the minus 3 come in. Okay, so what do I mean clean up the inside? What do you do in there?
you divide it into
Yeah.
minus 6.
Yeah, 16 divided by 4 is 4. And what do you do with those powers?
You leave them there.
No, you subtract them.
So think about what y to the 11th is. We have y to the 11th over y to the 4th, right? So you notice what I always do. I always just go back to what things really are, right? Just think about what this means. Y to the 11th, doesn't that mean 11 y's? 4, 5, 6, 7, 8, 9, 10. I'm not saying you should write this out every time. But I'm just going to do it once here to give you the idea. And y to the 4th is 4 y's. And so what's going to happen there? They're going to cancel, huh? Things on the top and the bottom of a fraction. So what are we left with? 7 y's. So what would be the quick rule? What do you do with the 11 and the 4? Subtract them, huh? That's the rule. Yeah, subtract them. Right? Do you see how I'm coming up with it, though? I'm just looking at what y to the 11th really is and what y to the 4th really is, and they're top and bottom of a fraction, so they've got to cancel out, don't they? So we're left with 4y to the 7th to the minus 3. We good so far? You know, let me pause right there, and we've had a lot of rules now. Let me summarize the rules on this one page, so it'll be on the YouTube and everything. So, and I'm going to add to it, because we just did 2 more, and I didn't really write them down. So, multiply numbers in the front. That was our first one. Add powers. And our second rule was powers outside parentheses. Outside parentheses. Multiply powers inside. Number 3. Negative powers. I'll just write it in words. Negative powers jump to the other side, then become positive. Okay, so the 2 new rules that I just didn't mention. If you have x's like to the 3rd and x to the 7th, that's x to the 10th. You add powers on the same line, don't you? Right, they're lined up. Versus if you have x to the 7th over x to the 3rd, it's x to the 4th. You subtract powers top to bottom. So those are 5 rules we've seen now. Kind of putting those together. Right? So top to bottom, you subtract powers.
So technically when you're simplifying, you're technically subtracting.
Yeah, simplify is a general word that can mean a lot of things. Yeah, it's all simplifying what we're doing. Yeah. All right, so on this one, so we divided the 16 and the 4, and we subtracted the powers, because they were vertical, right? They weren't sideways. So we subtract the powers. Now, what are we going to do with that negative 3? Now that we have the inside a little cleaner, what's going to happen with that negative 3? Powers outside parentheses. Rule number 3, powers outside parentheses. Boom. And what other power's in there?
1.
Invisible 1. Boom. So that'll be 4 to the minus 3, y to the minus 21, right? 3 times 7? 21. And I can't leave my answer with negative unhappy powers. So what's it going to do? They're both dropping down. In other words, this one will go down to become 4 to the positive 3, and this one will go down to become y to the positive 21. I've got nothing on the top. So you put a 1, huh? Everything left the top, right? Both those guys jumped down. They were both unhappy, both negative powers. They both jumped down. And then what is 4 to the 3rd? Yeah, use your calculator. 4 times 4 times 4. There it is. Does that make sense? All right. Let's try that one. The first thing I would do on this problem is let the negative powers jump. Let the ones that are unhappy jump. Which ones are unhappy? Which ones have negative powers?
-5 and -6.
Those two, right? Everybody else is staying put. Everybody else is positive and happy where they're at. Those two are going to swap, and then the powers will become positive, and then take it from there. Yeah, this is a good one to do. This one has some tricks. All right, so this guy's going down. This guy's going up. So e to the plus 6 and the m to the plus 5, and everything else stays put, huh? So e squared c, m to the 7th, c to the 4th. So far, so good? So the two negative powered items jump to the other side and become positive. Now we have to combine same letters, like these two E's are going to combine, and these two M's are going to combine, and the two C's are going to do something. All right, so what exactly do they do? What do you do with this 6 and this 2? Yeah, because when they're on the same line, they add, because this means 6 E's and 2 E's, doesn't it? It means you know what it means. So it's 8 E's. Okay, and what about the bottom? What is M7, M5? M12. It just means 7 M's and 5 M's. It's 12 M's. Now, what about the C's, though? What do they do? What's the power on this guy?
1.
Invisible 1. So we need to subtract, right? Perfect. That's rule 5. When they're vertical, they subtract. Yeah. But where do the extra, 4 minus 1 is 3, but where do those 3 go, top or bottom?
They're negative.
So here's, really, I know we're trying to do our best with rules and everything, but really, there's too many stinking rules in math to do the rules perfectly all the time. There just are. What's better than rules is really just thinking what the thing really is. And here's what I mean by that. If I was in the middle of a test, and I'm like, trying to get this question right, I'm like, I don't remember, is it negative, power, jump, I'm confused. I would stop and go, wait a minute, what is c to the 4th? What is it? I mean, what is it really? All fancy rules aside. Doesn't it mean 4 C's?
Yes.
And what do we got up there? 1 C. So what's going to happen?
3.
One of these is going to cancel one of those. And where are the C's left over? On the bottom. C to the 3rd. Right?
Yeah.
That's always best. Just think about what's really going on there. That's easier than, because you got to perfectly memorize all the rules all the time. Does that make sense? So if you want a rule, though, to help, I will give rules as well. Yes, you subtract the powers, and wherever the bigger one is, that's where the answer ends up, huh? That's the actual rule, right? The 4th power was bigger than the 1st power, so that's where the leftovers are. They have a little battle, and they cancel, and whoever had more That's where it ends up.
It never matters if, say, there's 8, 10 on the bottom, it's not going to turn into a negative power. Because they're
Like if you had x to the 8th and x to the 10th on the bottom. You would just subtract them, and it would be x to the 2 on the bottom. Yeah, wherever the bigger one is,
Wherever the
Wherever
positive.
the bigger one.
because it'll end up positive there.
Yeah, you have
Yeah.
it from what you did from 2, 1, 4, 0.
Yeah.
It has to be positive.
Really, I'm giving you a shortcut. I mean, what you're saying is true. If you want the real, I hesitate to confuse you, but if you want the real rule is you can start with actually either one. It's just whomever you start with, that's where the answer ends up. That's the real rule. Let me show you what I mean. Because look at this. You know this is correct. What we just did is right. But you might say, and why did it end up that way? Because we started with the 10. 10 minus 8 is 2. And the answer goes where you started. So you mean you can start on the top? You can. 8 minus 10 is negative 2. And where's that going to go? Where did I start? The top. So it'd be x to the minus 2 on the top. Now, we wouldn't leave it that way. What do negative powers do? Same answer in the end. See the beautiful fit? So really, you can start with either one.
You're just going to have to do an extra step if you...
Yeah, it's best to not start with the smaller one. Yeah. But if you really want the real, true, deep rule, there it is, really.
It's why they always say, always try to switch over, the bigger...
Yeah, to the bigger one.
The smaller number first.
Yeah, move the smaller to the, yeah. So we start with the bigger one. That's the better way to go. Yeah, saves you steps. And there we go. Is that good on that? So the bigger one was on the bottom. Start with him. The difference goes on the bottom. All right. So many rules here. Let's see. Are we getting close to the end of this section? Got a few more. There's 14.
You did say the answer could be multiple choice, right?
They will.
Make sure the other answers don't...
Oh, no, they're tricky. No, I can. So multiple choice is by no means a giveaway. I've had many students tell me how tricky my multiple choice is. And I'm saying, yeah, I want to know if you really know. And so you got to know the stuff. If you know the stuff, you'll be fine. All right, so number 15. What? Look at those zero power things. What's up with those? 5x to the 6y to the 0. Let's see. So 5x to the 6y to the 0. And then, what was the other one? 2x to the 0. So what's up with the zero power thing? What does that mean? Let's do that on the side of our paper for a second. What is like 7 to the 0 power? 0?
1.
1?
I wrote that down.
Well,
1.
1.
2 to 0.
Good note taken. Yeah, we covered it earlier, remember?
Yes.
Yeah. Anything to the 0 power is 1. Now, that might seem totally bizarre, but remember we proved it just a minute ago. Remember, 2 to the 3rd came out 8. Let's go back. I'll rehearse this real quick. 2 to the 2nd was 4. 2 to the 1 was 2. And next came 2 to the 0. And then we looked at the pattern and say divide by 2, divide by 2. So 2 divided by 2. Yeah, you can do that with any number. Take 7 to the 3rd. It's some big number. And anyway, same pattern will work. It's 1. Anything to the 0 power is 1. It's true. So, okay. So that means this is 1 and this is 1. They are. So it's 5x to the 6 times 1. And this is 2 times 1. And 1 doesn't do anything, right? 2 times 1, that's just 2. And 5x to the 6 times 1, that's just 5x to the 6. They basically vanish, don't they?
Yep.
And now can we finish this up? What's 5x to the 6 times 2? You've done so many fancy rules now. You might be thinking of something hard. It's just 10. Yeah, nothing fancy there. We've had so many fancy rules. It's just 10x to the 6. Just multiply the numbers in the front. We good there?
I didn't even have time to write that.
Are making sense? All right, are we close? I think we're close to being done with this section, which is good. We got an hour for the other section. Oh yeah, no, 16 is good. 2x squared to the 0. 2x squared to the 0. Answer is? What did we just say? anything to the 0 power. What if you, what is 7 to the 0 power?
1,
What is 2 to the 0 power?
2.
What is blah, 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 blah to the 0 power?
Blah, 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 1.
Well, yeah, so it's always 1, isn't it? Good? They're just testing that you're consistent on that rule. All right.
So all you do is, on that one, you just drop the parentheses, bro.
Yeah. 0.00836. Or let's start with number 8. Let's do them back. It'll be easier. 9.56 times 10 to the 7. 9.56 times 10 to the 7. Okay. Okay, yeah, let's go this way. So, what is it? They want us to make that like a normal number. What does that mean when we have 9.56 times 10 to the 7th?
They'll move it 7 places, right?
Good, yeah. Remember what it does to multiply a number by 10? Like if you have 2.39 or whatever, and you go times 10, what happens? Moves the decimal 1 place, doesn't it? And it becomes 23.9. Right? When you multiply a number by 10, it moves the decimal 1 place. Right? Think about money. What if you have $12 times 10? Or no, what if you have $1.20? What if you have $1.20 10 times? What's it going to become? It's going to move the decimal 1 place. $12, of course, huh? $1.20 10 times. So multiplying by 10 moves the decimal 1 place. So what if you multiply by 10 twice? It'll move it 2 times. If you multiply by 10 3 times, it'll move it 3 times. You multiply by 10 7 times? Just move, yeah. It'll move the decimal 7 times, right? So 9.56. So I'm going to take that decimal, and it's going to move, I'll just write a note here. It's going to move 7 to the right. 7 to the right. So, okay. So here we go. 1, 2, and I'm to the edge of the number. I have 5 more to go. What happens? Brings in zeros. Once you get beyond the edge, it brings in zeros, doesn't it? 2, 3, 4, 5, right? Because it's 1, 2, 3, 4, 5, 6, 7. There we go. So it moves 7 to the right. What is that? 1, 2, 3, 4, 5, 1.
95,600.
It is 95,600,000.
95 million. Thank you.
Is that good? The decimal's right there. So yeah, so whatever power is on a 10 moves the decimal that many places to the right. Good question. It does. You're exactly right. So 9.56 times 10 to the minus 3, let's say. What if they gave me that? Then you would go 1. You're going to go 3 left. Now this means 3 left. 1, and you're to the edge. 2, 3, those bring in zeros, huh? 00956.
You left with 9 cents in your bank account.
Yeah, not much, huh? We good there? That makes sense? All right, and now 17 is going to have us go backwards. That's what's harder. 0.00836. Okay, 00836. So number 17, 0.00836. What they want us to do is write in SN. Oh, I should write out what that is. Not a good time for abbreviations. Scientific notation.
Oh, yeah, you could go SN. Or SCIN.
Yeah, I will at this point forward. So scientific notation. Now, what does scientific notation mean? It means put the decimal after the first digit times 10 to some power. So that's what scientific notation is. It's you have to put the decimal after the first digit, times 10 to some power. Okay, well, so we have this number 00836. So where am I going to put the decimal? Yeah, I should have said after the first digit that's not 0, but I think you knew. I think you knew what I meant. Yeah, after the first digit that's not 0. So yeah, so after the 8, right? So it'll be 8.36. Let me bring it over here. 8.36 times 10. Now, the decimal, you with me so far? I want to make sure you're caught up so you can catch this thought. The decimal doesn't really go there, right? I mean, the decimal really belongs back here. The number's not really 8.36. We've artificially placed it there because that's what we have to do for scientific notation. But I've got to give it instructions, bless you. I've got to give it instructions to go back where it really belongs. So it's here artificially. So what power do I put on that 10 to make this go back where it really belongs? What is it? Yeah, beautiful. -3. Y'all see that? So it'll go 1, 2, 3, and it'll put in the zeros, and that's exactly right. So this number is really the same as the other number. It's just a different way of saying the same thing. It's like saying 1 and uno. You're saying the same number in two different languages. We're saying 8.36 times 10 to the minus 3. This is telling the decimal to go back 3 places, so it's really the same as that number. You're saying the same number in two different languages, right? Regular language and scientific notation.
Oh, okay.
Same number.
Sort of like computers needing.
Well, scientists use it because they deal with really big and really small numbers, like the width of a cell, and it's, they don't want to communicate and say, oh, it's 312, right? Instead, they want to say 3.12 times 10 to the minus 8. It's just a more clear way of communication. For super tiny numbers that have tons of zeros in them, super tiny or super big. That star is how far away, really tiny, really big numbers. It's easier to just do it like this. That's why scientists use it. Sure, it's a good idea. Let's do, how about, I'll just make up another one. How about, this will be, let's call it a do problem. Try, how about 0.0976. Write in SN, scientific notation. So 9.76, yep, 10 to the minus 2. That's the same number, isn't it? Just said a different way. They're saying the same number in a different language. Question? What's that? Yeah, back over here, when I told you what scientific notation was, it always means put the decimal after the first digit, times 10, it'll always be 10, to some power. Yeah, that's what it means to be scientific notation. You have a 10 to a power. Yeah. And the decimal's got to be after the first digit. Yeah, that's just what it means to be in that language. Yeah, exactly right. So we're saying the same number in their language, in that other language. Yeah. Is that good? Making good sense?